Hi, my name is Tom, and I'm leading the software and electronic organization in ZEEKR. Today, we will talk about electronic architecture of vehicle. Now, let's quickly look at the common challenge of distributed architecture. First, let's quickly look at ZEEKR, who we are. ZEEKR is a smart mobility technology company. We are a premium electrical brand in GTC holding group. We aim to build up a clean, green, smart mobility ecosystem worldwide. Here are some key milestones of our journey so far. April 2021, we released our brand. In the following August, we finished pre-A round investment of $500 million. Then October, we released our first car, 001. As you can see from the right, it is a very beautiful and a powerful car. September 2022, we launched our partnership with NVIDIA, and we will be the first out with SolarSock. October, we have reached single month delivery more than 10,000. January this year, released our second car, 009. It is a very beautiful MPV. Just last month, we have finished our A round investment of $750 million. Now, let's start our journey on electronic architecture. First, what is the electrical and electronic architecture of a car? Let's look at the classic definition here. It is a software and hardware system that integrates sensor, ECU, harness, and electrical distribution module to design and optimize full vehicle control. That is very classic, but not that straightforward. Let's try from a simple way. We move to the right part of the material. Let's try to see it from two angles. What included in the architecture and what the main problem it solves. It includes ECUs, sensors, actuators, harness, network communications. I would say basically everything in the car relates to electronic and electronic. It also solves the main problem like the electrical connections, network communications, and logic function allocation. Furthermore, let's look at some real examples of the cars and their EA. In the left part, it is a car around, let's say, 100 years ago, and below is its architecture. Actually, it's quite simple. Two front lights, the horn, two rear lights, and of course, the battery and the harness. In the right, it is the 001 we released at 2021. In that time, we have more than 100 ECUs, the electronic control units in the car. More than 50 of these ECUs are capable of the software upgrade over the air. We are doing frequently software updates to these ECUs over OTA today. Let's together look at the common challenges of distributed architecture. It is a real example of the climate control in the car. In the left is a system design, not very complex. Now, as to achieve a new user scenario, like to improve the degree of comfort in a wet and warm weather situation, which will require the adjustment of a cup basic function logic and affect several ECUs. The right picture shows the implementation situation. In this very simplified situation, the climate control unit needs to talk and cooperate about 10 more ECUs. Such a change will take months and a lot of money and effort to make it. What is the trend of the E-architecture? In the left side, it is a picture from Bosch Engineering. It gives a very clear layout of the roadmap of the architecture from distributed to the centralized. And in the right, it is also a typical example from Tesla. Before Model 3, it is also the traditional distributed architecture. And in Model 3, it has made a big development, goes to the centralized. The reason behind it is quite simple. Improve the efficiency and lower the cost. Now, let's look at what we are doing today. ZEEKR Centralized Computing Platform. Internally, we call it 3.0 platform. Very briefly, it has the Ethernet ring as a backbone. It has three very core components. The core supercomputer, CSC, two zone controller right, zone controller left. We will talk about them more in coming slides. The new platform significantly reduces the numbers of ECUs in the car. For example, the base car version, the whole ECUs of the base car version is less than 20. It is also a global platform, includes the function safety requirement, cybersecurity requirement. Now, let's look at the very core component, the core supercomputer. It is one box, includes AD, ADAS, smart cockpit, and vehicle control. As you can see from the below diagram, it's a blade configurable solution, which is equally important or further important is about the operation system it is running. The ZEEKR OS, the Unified Vehicle Operation System. We will talk about it in the coming slide. Today's solution is using Orin, and the next step is Thor. Now, let's look at the room controller. What is a room controller? In a very simple way, it is based on the location, integrates the functions in the area. It contains edge computing, smart power distribution via e-fuels, network gateways, atomic services, and of course, function safety for the critical functions like chassis control, like power. We have two zone controllers in today's solution. The right one mainly integrates the body function, and the left one mainly integrates the power and the chassis control function. Now, come to the vehicle operation system, the ZEEKR OS. It is a generalized operation system with in-house BSP, customized kernel, and hypervisor. And the internal team spend quite a lot of energy in developing the middleware. It is cross-domain deployed in the AD, vehicle control, smart cockpit system. Through the unified COM and service framework, it achieves the complete cloud, vehicle, phone, service-oriented architecture. Equally important, it also provides the end-to-end development toolchain, like the simulation, like the test, like the configure. Full function in Q2 this year. Performance optimization will be done at the end of this year. As to accomplish what we talked about, the centralized E-architecture, the operation system, we do need the right people, right team, right organization, procedure, and toolchain. Basically, car OEMs moves to the high-tech company. Below is a DevOps practice in ZEEKR today. The ZEEKR Continuous Integration Plus platform. The team spent 6 months to build it from zero to today. 1 hour build, 15,000 test cases, 5 minutes automation test for the whole ZEEKR OS. The team is very proud of it. short summary of what we talked today. We talked about the centralized E architecture. We talked about the operation system. We also emphasized DevOps. Thank you.